Patel, and I am here to demonstrate our DA352 Privacy and Information Security course project. My team constitutes of 4 people, namely myself, Ronit Patel, Prakhar Punj, Omkar Harishchandra Shinde, and Sahil Raj. So our project is based on creating secure chat app which uses uh, handshaking, authentication, encryption, and decryption processes. I have used OpenSSH library in C and C++. So first I will demonstrate how my project works, and then I will move forward to explaining the entire uh, handshaking, authentication, encryption, and decryption process through the code. So firstly, I will be creating a port where that port will be listening for clients. So before that, I will be compiling all the codes together. So that could be done by using this command make. So it takes some time. Let us wait for a few seconds. Hmm. So now the compiling has been finished, and you can see that .d and .output files as well as .exe files have been completed. So you can see in my code base I have 3 important files, which is Diffie-Hellman.c, Diffie-Hellman uh, example.c, and chat.cpp. So for sharing for creating secure channel, I am using Diffie-Hellman, and chat.cpp comprises of the authentication, encryption, and decryption part, as well as the GUI part. So I have also created graphic user interface. So coming to so first I will start my server. That could be done by chat.exe/listen. I will be listening at port number 1337. So let's start the server. Okay, so you can see that it is listening on port number 1337. Now I will be now I will be starting the client, so both of them could chat with one another. So chat.exe/p, and I need to write the same port. So this will start my server. Sorry, client. So you can see here the server is listening, and here the uh, client is uh, communicating with the server. So I can send a message, hi, and here also you can see we can send the message. So this is I have created a simple graphic user interface through which we can communicate. This can be these two, server and client, can even communicate if they are on different PCs, but they should be on the same LAN connection. So let me give you another. So how are you, and it is visible, and here we can write I am fine. So this is my project. Now I will be explaining the handshaking, authentication, encryption, and decryption processes in this secure chat application. It is being implemented in the files chat.cpp and Diffie-Hellman.c and Diffie-Hellman example. So first let's start with the handshaking part. So for handshaking part, I have created 2 functions. First one is init client network, and the another one is init server network. Okay, so the handshaking process establishes a connection between the client and the server, ensuring both parties are synchronized before proceeding with key exchange and communication. So in server mode, which is written within this function, it sets up a listening socket on a specified port. By default it is 1337, as I mentioned earlier, and it waits for a client connection using accept. In client mode, init client net, so here you can see in the server it is waiting for the handshaking. These are the functions required. These are the statement required for doing this. Similarly, in the client network, also I am sending SYN, which is generated by ISN. It is a 32-bit unsigned, which ranges from 0 to this integer. Okay, so the server receives the ISN, then it increment it by one, appends acknowledgement and send it back to the client. The client then verifies that the received value, that is -1, matches the original ISN. If it does, the client sends acknowledgement back to the server, and then the handshaking is completed. Both parties use the ISN as a seed to generate an initialized vector for AES encryption using the IV generation function, ensuring both have the same IV for symmetric encryption. So let me show you the IV gen function as well. Uh, so you can see this is the IVGen function which generates IV for the SYN request. Okay, I will not be going into the detail of this function as it will take too much time. So then I would be moving forward to the authentication part. That is authentication and key exchange process. So authentication in this context refers to establishing a shared secret key securely using the Diffie-Hellman key exchange protocol, which ensures that both parties can trust the integrity of the communication channel through subsequent message authentication. So the Diffie-Hellman parameter are initialized in this dhparam.text, which is q, p, g is the generator, and q and p are the two secret keys. Not the secret keys, they are the numbers. So okay, so if this dhparam.txt part file is not present, then we can also generate these also, and this generation can be seen in this Diffie-Hellman example.c program. So if it checks that if it exists or not. So if it exists, then it only reads, and if it does not exist, then it generate. So generation part init function has been written in Diffie-Hellman.c part. Here the entire implementation of Diffie-Hellman is there. So you can see that this is the init part where we are using Q, P and G. So Q is the small prime, it should be 256 bit or larger. P is the large prime, which should be 2048 bits or larger, and G is the generator of it should be the generator of the group of order Q. I will not go in detail of these code as it will take a lot of time. So each party generates a secret key, that is private key, and a corresponding public key using dhgen. So this is the dhgen function which generates the public key, and the secret key sk is a random exponent modulo q, and the public key pk is computed as g raised to the power sk mod p. So now coming to the public key exchange, so the server send its huh, 1 second, yes, here. So the server send its public key to the client as a hexadecimal string. The client receives the server's public key, stores it as BPK, and sends its own public key back to the server. The server stores the client's public key as BPK. Now coming to the shared secret computation part. So both parties compute the shared secret using DH final, which is again in the Diffie-Hellman.c file. So this is DH final, and using this we again create the shared secret key. So this function calculates the shared secret as pk yours raised to the power sk mine mod p. Here it is being written. Let me show you once. Mm, yeah, this is this part. Now the shared secret is then processed through the HMAC based key derivation function, that is HKDF, using SHA 512 to produce a 512 bit key. This key is split into two 256 bit part, one for a one which is used for AES encryption and another which is used for HMAC authentication. So we divided into two parts of each of 256 bits, and then we one is used for HMAC encryption and an authentication, and another one is used for AES encryption. Now coming to the encryption process. So encryption ensures that message sent between the client and the server remain confidential. So when a user types a message, so these all typing part and GUI part is written in this code in this program as well, but that I will not go deep into. So coming to the HMAC computation part. Huh. Coming to the HMAC computation part, before encryption, an HMAC is computed for the plain text message using the HMAC function. This uses the HMAC key derived earlier and SHA-512 as the hash function, producing a 128 character hexadecimal string. Uh, the HMAC is prepended to the original message, creating a combined string of HMAC plus message. So here the HMAC key is created, and here we combine it in this uh, part. Okay, now coming to the AES encryption part. So the combined string, that is HMAC plus message, is encrypted using AES 256 in counter mode by the CTR encrypt function in chat.cpp. This uses the AES and the IV generated during the handshake. CTR mode turns AES into a stream cipher, allowing encryption of data of any length without padding. The encrypted output ciphertext is sent over the socket to the other party. Now coming to the last part, that is the decryption part. So decryption ensures that the received message can be read and verified for integrity. So the received message is a function. Let me show you. Okay, it is written down below. So it listens for incoming data on the socket and stores the received ciphertext in a buffer. The ciphertext is decrypted using AES 256 in CTR mode by the CTR decrypt function. This CTR uh, the decrypt function is here as well. This produces the plain text, which should be the HMAC plus the original message. So coming to the HMAC verification, the decrypted plain text is split into the received is reverse engineered, and thus it is split into received HMAC and the message content. A new HMAC is computed on the received message content using the local HMAC key. The computed HMAC is compared with the received HMAC using crypto memsep function. Here it is, and to ensure integrity. If they match the message, if they match, then the message is authenticated and untempered. Otherwise, if they do not match, then we can consider there is a man in the middle attack, or someone is mimicking the server. So, and if it does not match, then HMAC does not match is displayed to indicate potential tampering. So this was our whole project for this DA352 course, and I along with my other three members of the team, that is Prakhar, uh, Onkar and Sahil, have done a very tremendous task in making this project successful. Thank you.